Hello, people, and welcome back to another session. In this session, we'll be looking at t-test to infer about our regression coefficients. So, in our previous sessions, we covered how to do a statistical inferencing for our regression coefficients using f-test. Now, in this discussion, we'll be going over how to do the same process using t-test. Now, because we have already studied t-test before, the principles and the concept remains the same. Just a couple of pointers that you need to take care. So I'll remove the ANOVA table because you don't need an ANOVA table for a t-test. You needed it for an f-test, but for t-test you don't need it. So for t-test, it is the t-test for statistical inferencing for regression coefficient. It is conducted at n-2 degree of freedom. And because our null hypothesis was that there is no linear association between the two variables, and our alternative hypothesis is to find out either there is a positive association or a negative association, but the alternative hypothesis encapsulate both the scenarios. There, there can be a positive association or there can be a negative association. So here, this is an example of a two-sided t-test. So for this particular scenario, what will be the value of our test statistic? The value of our test statistic, or t, will be equal to beta 1 estimate divided by standard error of beta 1. This is going to be my test statistic for my t-test. And because we have understood t-test beforehand, you know how to calculate your critical t-value. You will be using your concept from double-sided t-test according to the significance level given. So in our previous discussion, we discussed about doing a statistical inference test for our student data set, and we discussed how we can find the alternate hypothesis or evidence against our null hypothesis using f-test. Let us do the same thing for t-test. In our previous session, we already created the model and we passed it to the ANOVA function to get our ANOVA table. There is another function in R called summary function. If you pass your model to the summary function, it is going to give you a much more detailed result when it comes to your model parameters. So here for the estimate, or sorry, for the intercept, you have your estimate, standard error, t value, and p value. You have your r squared value, your f statistic value, everything. So as I told you, your value of test statistic is going to be your beta 1 estimate, your estimate for the slope, divided by the standard error of the slope. So for this particular example that we have, this value will be equal to 5.012 divided by 0.4934, right? This is how we calculate the test statistic. So let us do that calculation over here. Now test statistic value, test stat, is going to be equal to 5.0121 divided by 0.4934. Now if you print this, this comes out to be 10.15. Now this 10.15 we need to compare with our test status, our critical t value. I'm so sorry. So we are doing this test at 0.05 alpha level or 95% confidence level. So because this is a double-sided test, to find the critical value, so because this is a double-sided test, we have to find t critical. This area right here, this is 95%. These two areas combined, this is 5%. So each of this is going to be 2.5%. This is 2.5. This is 2.5. So my total area to the left of my critical t value is 95 plus 2.5, which is 97.5%. This is the probability to the left of my critical t value. So I need to use qt to find out my critical t value. So test crit is going to be qt 0.975, and this t test, as we mentioned, is done at n minus 2 degree of freedom. So 29. This is 2.0453. So again, I can see that my critical t value is less than my test statistic. So we have sufficient evidence against our null hypothesis, which is the same result that we got when we did our F test. Now we will also touch upon the confidence interval aspect and juxtapose that with our hypothesis testing. So now for the confidence interval aspect, I want to calculate the confidence interval for my population parameter or beta 1. So as we studied beforehand, my confidence interval is equal to estimate plus minus t critical into standard error. So in this case, if you replace the values here, you can calculate the lower bound and the upper bound. So your estimate for beta 1 is 5.0121. You subtract that with your critical t value, which is nothing but test crit, into your standard error for beta 1, which is 0.4934. Okay. Calculating the upper bound, I'll be getting upper bound, and I just need to do a plus. So what is my upper bound and lower bound? So my confidence interval for my population parameter or slope is between 4 and 6.02. This is my confidence interval. So here you can see that your initial value at null hypothesis, which was 0, it does not lie in between the confidence interval, it lies outside the confidence interval. So from this, you can clearly surmise that because your point does not lie, or your initial point does not lie in the confidence interval, and it lies outside the confidence interval, therefore you have sufficient evidence to go ahead and reject the null hypothesis. So this is how you perform t-test for statistical inferencing for our regression coefficients. Thank you so much, guys. I'll see all of you all in the next session. Thank you.